Today is 10/4/16, and we're going to talk a little bit more about DNA replication and what can go wrong. We're going to talk about what can go wrong. And we said out there that a mistake in copying DNA is called a what? Mutation. And I said you're all a bunch of mutants. We're going to, oh, you have no idea how true that is. We're going to talk a whole lot about mutants this year. Fatty water bags and mutants. I'm a mutant, you're a mutant. Wouldn't you like to be a mutant too? Oh, wait, you are. Huh. And the topic of what we're going to do today might as well be called, what could possibly go wrong? Because we're going to figure out everything that could go wrong, and then we're going to make it go wrong. How's that for crazy? Okay. Is there any specific order in which these have to occur? No. Not in any way that we can understand, sort of as mere mortals. And I'll draw my little side wall, the sides of the ladder, remembering that these are sort of two halves. We can split them apart. And of course, in its final form, this is twisted. We take it and we sort of give the whole thing a twist. So when we copy DNA, we call that what? Copying your DNA is called replication. So we're going to do some DNA replication. So we're going to take half of this DNA and we're going to move it out of the way. We're not going to worry about making two strands right now. We're only going to make one strand. But we're going to go ahead and plug in some matches. Except I'm going to do something weird there. Okay, who found the error in my replication? If you haven't found it yet, keep looking. When you've found it, I don't know, stick your thumb on your forehead, do something ridiculous, make moose antlers, stick your tongue out, cross your eyes, I don't care what you do. Twitch. Twitch. People will think I'm torturing you all. I keep threatening to electrify the seats, but I haven't figured out how yet. Okay, you found my mistake? Where is it, Madison Rice? Yeah, here, where there should have been a G to partner with, there should have been a guanine to partner with that cytosine. Instead, this cell, whatever cell this could be a cell in your skin. This could be a cell in the skin on your nose. This could be a cell in your liver. It could be a cell in your bone someplace. Instead of a guanine being put in there to copy, somehow an adenine got stuck in there. So the cell, when it was copying the DNA, substituted one letter for another. There's a specific name for that kind of mutation. This is really creative. Never forget, scientists are very, very creative. Do you know what that kind of mutation is called? Could anybody guess? Is your imagination powerful enough? It's called a substitution mutation. I know. Really, really earth-shattering. It's a substitution mutation. That's really pretty obvious. We have other kinds of mutations that we're going to talk about, but substitution is one kind of mutation. We have substituted one base for another. We made a mistake in copying, and we've got one base that just got substituted. We have not, notice, changed the overall number of base pairs. Number of base pairs didn't change. So in a substitution mutation, we just have, it's real simple. One base gets swapped in for another, but the overall number of base pairs, the length of the DNA strand, doesn't change. Nothing changes there. Okay, cool. Everything still lines up. It happens at one specific point in a strand of DNA. That idea is important. We'll talk more about that as we go. So that is the first kind of mutation we're going to talk about. Let's look at a couple other kinds of mutations. So we're back to our original DNA strand that we built. We have 9 base pairs. And once again, we're going to copy this DNA strand because, remember, every cell in your body has to replicate its DNA every single day. You know, we should look it up. I don't know what the life expectancy of one of your skin cells is? I would guess it's probably a few days, maybe a few weeks. I don't know. But when that skin cell dies, there has to be one to replace it. And so it has to replicate its DNA. And you've got millions upon millions of cells. So they're all replicating DNA constantly. Like I said, you're making about 10,000 mistakes a second. Later we'll talk about why that's okay. You're actually fixing most of them. You're fixing 99.99% of them. So you can make a lot of mistakes as long as you fix them. Okay, so we've got this strand of DNA once again. We're going to move one half out of the way. In normal operation, we would copy both halves of it, so we end up with 2 new sets of DNA. And we'll probably do that a little bit later. We'll practice that. So I'm going to go ahead and fill in some matches here. I'm going to make a trickier one. Do you see my mistake? Who sees my mistake? If you see my mistake, put your hand up, stick your thumb on your forehead, stick out your tongue, cross your eyes, I don't know, twitch, whatever. Okay. Here, you found my mistake. It's not as simple as it seems. Tyler, what do you think?
Okay, so the C is paired with a T.
A C is paired with a T.
A is paired with a C.
Okay.
A G is paired with a T.
So, here's the question I have for you, and I want you to be careful. Did I make 1 mistake or did I make 3 mistakes? Or did I make 4 mistakes? So, 1, 3, or 4. I guess those are the, or if you have some other number, hold that up. 0 mistakes. It's awesome. 1, 3, 4. How many mistakes did I make? I see 4s and I see a 1. I like that 1. Tell me why you think it's 1. It's really only 1 mistake to start with, but boy, it turns into a whole bunch of mistakes. What mistake did I make? What did I do, Sawyer? I'm missing a G, and if I took these 3 and moved them down, would everything be right with the world? Well, if I put that G back in there. But something got missed. It's as if a letter was deleted. It's as if a base was deleted. So you're right, I was missing 1 thing, but then, and you both found different things, then nothing else lines up. So once you're missing 1 thing, it's like missing a button on your sweater. My daughter is 4, she is learning to button sweaters all by herself. And so she will come out of her room with a sweater on, very proud that she has buttoned it, except there are 2 buttons up here and 2 buttons down there and nothing quite meets. But hey, the middle looks okay. If you delete 1 thing, if you miss 1 thing, it causes a waterfall of problems. Okay, this is called, oh, once again, biologists so creative. There's a special name for this kind of mutation. Can you guess what it is? It's a deletion mutation. It's a deletion mutation. In a deletion mutation, 1 base is skipped or deleted. This can cause other mutations because things don't line up now. And it can also change the number of DNA base pairs. So a deletion mutation can in fact change the number of DNA base pairs. That's bad. So we're back to our original strand of DNA, 9 base pairs, perfectly matched, no issues, but DNA has to replicate all the time. DNA in your eyeballs, DNA in your skin, DNA everywhere in your body, everywhere in the body of a maple tree, or a dandelion, or a whale, or a mouse, or a grasshopper is replicating. So I'm going to replicate this strand, but I'm going to make another mistake. You find it. Okay, I've copied my strand. I've made a mistake. If you know where the mistake is, do something ridiculous. Okay, you don't have to do anything ridiculous. You can just T-Rex. Haley, I don't know if that's a secret signal. Okay, okay. What you got?
There's 2 C's lined up.
Okay, there are 2 C's that are lined up. C does not partner with C.
And there's nothing, like on the last one, there's nothing for T.
Okay. So those are both things that are wrong with this strand. The question is, that's correct. The question is, what's the mistake? Jordan, what do you think?
The extra C was out there.
Oh. So if we were to take this C and get rid of it and move all of these up, would everything be right with the world? But we can't do that because guess what? This C has gotten inserted into this line of code, into this line of DNA. Okay, you're getting the sense of how creative biologists are at this point. What do you think this kind of mutation is called? So in an insertion mutation, an extra base is inserted into a line of code. And this can cause other mutations. Okay. An insertion mutation means that we've had an extra base that got inserted into a line of code when it was being copied. This can cause other mutations because like a few of you said, well, there's nothing to partner with this T. Well, you know, these 2 aren't lined up and these aren't lined up. So now suddenly we have these what look like substitution mutations, but really they originate in an insertion. We jammed something in there that didn't belong and now everything else is off kilter. It can change the number of base pairs that you're working with. We see that now this T is kind of hanging out there in space all by itself. That's bad. If this DNA sequence splits again and copies, then you're going to have a whole bunch of different bases in there. So it can cause sort of a waterfall effect of other mutations. Okay, 3 kinds of mutations. Going back, substitution, deletion, insertion. Here's the thing. These mutations all happen at one given point in a piece of DNA. And so all of them are considered point mutations. So point mutations include insertion mutations, deletion mutations, and substitution mutations. What we're going to do next, I'll give you a few minutes to write out definitions part C for those 3 that we just did. And you may want to add substitution mutation to the bottom. And then we're going to go out in the hall and you're going to do some mutating for me. Good job. Tomorrow, what you're going to have is a recall quiz on mutations. So you should know those 3 types of mutations. Substitution, insertion, deletion. You should have been able to finish part C on point mutation, deletion, insertion, and if you can add substitution to the bottom, you don't have to do A and B obviously, but you know what it means if you substitute something. You had a substitute teacher in here for a week. You know what that means. So tomorrow again, recall quiz, and probably another short video from Stated Clearly with another questionnaire for it. I will not be here. I got to go see my guy. He's going to go look at my stuff. It's looking better. If I can quit playing with it. But then Thursday, we're going to start to talk about what these mutations mean. And based on that first Stated Clearly video you saw, what does DNA actually do? Gives you a blueprint to build what? It's okay if you don't remember. Just I want you to be thinking about that. So tomorrow, recall quiz on mutations and another little video quiz. If you missed our conversation yesterday, I'm going to reiterate, and I had some additional sort of, here, let me